Hello Internet, I'm Sean.
I'm Aaron.
I'm Kevin.
I'm Brittany.
And we are all engineering students at Lamar University in Beaumont, Texas. And today we're going to talk to you about laminar flow. For those of you who don't know what laminar flow is, Aaron is going to tell you all about it.
Alright, so laminar flow is going to depend on your Reynolds number. Your Reynolds number is going to be your rho, V, all over your mu. Your rho is going to be your density, your V is going to be your velocity, your D is going to be your diameter, all over your mu, which is going to be your viscosity. And if your Reynolds number is below 2,000, it's going to be laminar flow. If it's above 4,000, it's going to be turbulent flow. However, if it's between 2,000 and 4,000, it's going to be transitional flow.
I'm going to explain the materials that we use. For this project, we used a couple feet of 4-inch PVC pipe, a couple of 4-inch PVC test caps, some screen door mesh, some cheap scouring pads, 5-inch coffee stirrer straws, aluminum cans, and some all-purpose cement, as well as some sandpaper to get it all smooth. Brittany here is going to explain the challenges that we faced in this project.
So right now you actually see our finished product. We had to do a lot of work to get everything working. This was one of our first test caps that we actually did. The test cap material was too cheap. That was one of the biggest things that we ran into at first. You can definitely see through the camera right here that it definitely had a hard time cutting it and has very jagged edges. So what we did after that was we looked for some better quality test caps, and we were able to make clean cuts. So what we actually did was 3 different nozzles. Our first nozzle is 3/4 inch hole that goes right through the test cap, and then we actually had to cut the aluminum to about a 1/2 inch hole. You want the aluminum to actually be smaller than the test cap. That's going to make sure that the flow comes out with no disturbance. For this one right here that we did 3 separate holes. Each hole was actually pretty difficult to do. I first started out with laying the test cap and the aluminum piece on top of each other and cut each hole out at the same time, or during the same cut. So this one we actually had to sand down and use this tool right here to actually shave off part of it to make sure that it did fit correctly. This last one is a elongated slit. The whole purpose of this one was to get a waterfall effect. We actually had to send this one to a shop and get milled because we were having a very difficult time getting the cut on it. This was our first attempt right here. We decided to do 1/4 inch holes and see if we could connect them and sand it down. Didn't really work too well. It wasn't a smooth edge. But this one right here, you'll see in our actual testing video, there is a very clean cut. So other than that, those were most of our challenges that we did experience during our build of these. Now we'll go to the assembly.
Due to some technical issues, we actually lost the audio part of this video, so Brittany's going to start explaining now.
Okay, so in this part of the assembly, what we're doing is we are taking our cut 1/2 inch rings with the mesh and inserting them into our 4-inch pipe. The purpose for this is so that we can actually hold our straws and scouring pads in place. It will also help prevent air bubbles from rising. So in this part of the video, we are actually trimming off the excess part of the mesh so that we can slip it further into the tube. Okay, Kevin has cut off all of the excess portion of the mesh. So once he finishes that,
Now we're going to push it further down into the tube so we can actually create a little bit of space that we can insert our nozzle into. You push it down about 2.5 inches so that you have plenty of space for the test cap and the nozzle entrance. So after flipping over the PVC test cap, we're now going to actually start inserting the coffee straws. We used 5-inch coffee straws so that we could actually fully fill up our PVC pipe. It took us nearly 1,000 of them to get it to fill this one pipe. So for both of them, we actually had to use almost 2,000 straws. She chose to use coffee straws instead of regular straws because their smaller diameter is going to help us slow down that water even further, as well as get them all lined up and the water moving in the same direction. So as we're inserting the straws, we're very careful not to bend or damage any of them, because doing so would actually disrupt our water flow and prevent us from making a laminar device.
So at this point, we have all of the straws in place in our 4-inch PVC pipe. You can see from our picture that they are all aligned and we are not crushing anything. So once we have them all in place, what we'll actually do is take our scouring pads that we've cut and place all 3 of them inside. The purpose for this is to slow down the water coming from the hose so that there's no turbulence, and that when it does go through the scouring pads, it will go through the straws in a parallel fashion. So what Kevin's going to do now is take the ring and the mesh and insert it. Okay, so now that Kevin has placed in the ring and the second layer of meshing, we will actually be pushing that further into the pipe. What our goal is to make sure that that is touching the scouring pads. The reason for this is to keep everything in place. You don't want anything moving when the water does start flowing through there. So that's what you can see from this point. Now we do have one more layer of meshing and a ring to put in, so that's what we'll be doing in this section right here. So with this section, we actually had to move everything down, and to do that, you did have to go very slowly as to not knock anything out of place. So the reasoning for this is we are actually going to put our nozzle entrance, that will be from the hose into the nozzle, into the pipe, and that will actually hit our scouring pads first. This, of course, will help with the water flowing in and slow it down enough so that when it does go through the straws, it will be in parallel once it actually goes out of the exit nozzle hole that we've created.
So now as I finish cutting off this final piece, we're going to force down this last mesh ring to create some more space, again preventing air bubbles and the water from picking up any velocity. Okay, so now we have our exit nozzle. We cut a 3/4 inch hole into the PVC piping and a 1/2 inch hole into the aluminum. So what we did was we made sure to place them directly on top of one another on the test cap, so that the spacing of the aluminum was actually smaller than the PVC cap. What we did was tape it on with electrical tape to make sure that there was no aluminum showing or no edges showing. The purpose for that is to make sure that when the water did go through, it wasn't getting caught anywhere. So what we'll be doing here in a moment is testing it. We haven't glued anything yet, but this will just make sure that our nozzle has been sanded down enough and is smooth to get our laminar flow to come out. So now we just need to glue on our entrance nozzle. Sadly, the glue is going to take about 2 hours to actually dry, so we have one that we've already created, and we're going to use that one to test it. Since we haven't actually glued on the cap yet, we're actually going to just hold the exit nozzle on. So right now we're going to screw it onto the hose.
And right now you can actually see our completed glued test device. Kevin is now getting everything ready to test out. He will be holding the nozzle exit cap on there tight enough to make sure it seals and gets a good flow.
So now Brittany's going to turn on the water, and we're going to watch the flow come up very slowly, as it does. It's going to come up very even and very clearly as our device actually does what it's supposed to do and slows down the velocity of the water.
Kevin's making sure there are no air bubbles coming through at this point before we hold on the nozzle.
And that's the whole goal of this device, to slow down the water flow until it reaches the exit. And as it rows very evenly and smoothly, we're pretty confident that it will work. Now we dump out the excess water, and now we're going to test it with our exit. Because we haven't glued it, we're just going to hold on to it. I'm just going to hold it on, and Brittany's going to turn on the water. Alright, so as you can see, the water comes out very smoothly and clear. You can see my finger almost perfectly behind it. And as it flows down to the ground, it's almost a perfect line all the way through. There is going to be some leakage because we haven't actually glued or sealed this piece yet, but it is still going to work for us.
Was one of our for one of the other laminar flow projects that we made. We haven't attached the top yet, so we also made this 3-hole version one, which we made identical to our single-hole version one, but we just made 3 of them, obviously. We also made a sort of a rectangular shaped hole for this one as well that we're going to attach later on. But for now, we want to see if multiple exits affect laminar flow. So I'm just going to attach this like here, and we're going to test this horizontally, and we're going to test it vertically because we don't know if gravity will affect these streams and make them cross or not. And we want to make sure that if that does happen, then we can still see if laminar flow is possible if they were more spread out or something. So let's go ahead and turn on the water. I'm going to start it like this for now, let all the water fill up. And as you can see, it has a very strong laminar flow while they're separated. And then when they merge, it becomes turbulent. Now this is while it's horizontal. So now, vertically, we have the same effect. So it seems that laminar flow is possible to an extent with multiple exits. However, to make this better, we would probably have to separate the holes more so that they don't intersect as easily. Go ahead and turn the water off.
Rectangle piece. All right, whenever you're ready. As you can see, the image after the water is actually pretty clear. So we are going to say it is laminar flow. Now as we turn it upside down, like y'all be expected. I'd say it's still pretty laminar from what I can see. It may be at a higher rainless number, but not quite turbulent yet. Because you still see a clear reflection, a mirror reflection from the water. Alright, you know, be ready? Rectangular piece on as well. Great.
Gotta fill up first.
Now some more concentrated flow. As you see here, it's still laminar. Pretty streamlined in my opinion. Now I'm going to tilt it, let gravity do its work. And honestly, I believe the tape rectangular piece is pretty laminar compared to it without being taped. I'll tell you, this one is a more concentrated flow as well, compared to it being not taped.
I was curious to see, like,
We fully glued on the regular head. We're going to test it out. Go ahead and turn on. Just going to hold it upright to allow the water to fill. As it gets to the top, turn it up a little. And you can see this laminar flow. It stays completely together all the way down to the ground. I was going to turn it up just a little bit more. Increase the power on it just a little bit. That was the wrong one. Oh, is that it? Alright. So yeah, just getting laminar flow straight out the nozzle all the way down to the ground. Successful test.